So last time we spoke some about solutions, and just to recap, a solution comprises a solute and a solvent. A solute is the species that's present in a lesser amount, and the solvent is whatever is present in the larger amount. Typically in our course, we will deal with aqueous solutions, so the solvent is usually going to be water. In this diagram here on the top left, you can see the solute is typically a solid, like a salt or something like that. The solvent will be something like a liquid like water, and you add them together and you form a homogeneous mixture, homogeneous solution that has the same properties throughout, that looks the same and acts the same no matter where you look and where you take a sample from. It's not restricted to aqueous solutions. We're just dealing with aqueous solutions in this class, but there are many solutions that do not involve any liquids at all. There are many solutions that have two liquids instead, maybe two solids, a liquid and a solid, a gas and a solid, a gas and a liquid, and so on and so forth. But in this course, we'll deal with water-based solutions, and therefore will be an aqueous solution. But I just want to remind you what a solute is, and what a solvent is, and what a solution is. Okay. Another piece of terminology is diluted and concentrated. You probably have heard that outside of this class, but I will mathematically and formally define that here. And diluted solution pretty much would say that I have a dilute solution would have a very small amount of solute per solvent compared to a concentrated solution. So you can see here on a molecular level, if I were to zoom in here or here, it doesn't really matter where, because it's a uniform solution. The amount of solute that I have dictates how concentrated the solution is. If I have very little bit of solute, it is a dilute solution. If I have a lot of solute, it is a concentrated solution. The act of taking a solution that is concentrated and making it more dilute is called diluting. So basically, I can take a concentrated solution and I can dilute it. The act of taking a dilute solution and making it more concentrated is concentrating. I can concentrate a solution. And here is something you probably have seen. So this is maybe it's tea or something like that. If I take a tea bag and I try to steep it in water for a while, if I take it out after a few seconds, the amount of tea in my cup will be very small, and it's a very dilute solution of tea. If I leave it for a very long time, I'll brew it for a while, and I'll have a very strong tea, in which case I'm saying that I have much more tea than here. It's concentrated. Okay? I can, as I just mentioned with dilution and concentration, I could take this and I can dilute it by adding regular water. So if I take this and I add a whole lot of water, I will form maybe this again. You probably have done this yourselves with say sugar and coffee or something like that, right? If I put a whole lot of sugar in my coffee, it will be concentrated in sugar. If I put very little, it's going to be dilute in sugar. If I put too much sugar, I can add some water and it will dilute it, and it won't be as sweet to me. If I don't have too much sugar, I can add sugar and concentrate the solution so that it is sweet to my liking. And you can do that with any solute, like salt or anything like that. It's the same idea. Now we're in the business of quantifying things. So we will use concentrations to quantify how concentrated a solution is. And the mathematical definition of concentration in chemistry will be that of the molarity. There are other ones, and I'll mention them briefly, but the main one would be molarity, where it's just by definition, the ratio, how much solute I have to the amount of solution that I have, which I think makes intuitive sense. If I'm trying to tell someone that I have a very concentrated sugar water versus a very dilute sugar water solution, the one that has a lot of sugar should have a larger number. And basically, this would be solute. The sugar will be the solute. So if I have a lot of sugar, I will have a very concentrated solution, and the number would go up because I'm not changing the volume. Say, let's say I just add sugar to a cup of water. I'm not changing the volume appreciably, and so this number would go up and go up and go up, and the molarity would go up. And if I'm trying to dilute something, that means I am adding stuff here, and I'm reducing the molarity. So I think it makes intuitive sense in that sense, okay? Careful now here. The numerator here is the moles of solute, meaning it's the amount of solute that I have. Like, so if I have grams, I can convert to moles easily. The denominator, though, is not the volume of solute, and it's not even the volume of solvent. It's the volume of the whole solution, and it's in liters. It's always in liters. And by definition, dimensionally, moles divided by liters will give me this unit of big M, which is called molarity. And I can quantify now that if I have a solution, say here, that is 5M, this is read as a 5 molar solution. If I have 2M, or something like that, this is a 2 molar solution. Okay, this is more concentrated than this. This is more dilute than this, and they both need to see dentists. So the idea here is to quantify that using the amount of solute and the amount of solution that I have in any type of question that I have. Okay. So let's look at an example. I want to calculate the molarity of 40 grams of NaOH in 500 milliliters aqueous solution, okay, in water. So I have it solved out here for you. You can follow this along later if you want, but I will also do this here by hand for you. So here's a question. I want to calculate the molarity of 40 grams NaOH in 500 milliliters aqueous solution. I will take this as having 2 sig figs here and 3 sig figs here. Okay, we'll just play with it along. Okay, the first of all, the definition of molarity, as we defined, is moles of solute divided by liters of solution. Let's see what I have. First of all, SOL-N here, SOL-N. I use it a bunch, and it's an acceptable shorthand notation for the word solution. Okay, yeah, you may have seen me use this previously, but this is basically what it just means solution. All right. Liters of solution. I need liters of solution. Do I have that? Well, I have 500 mils of solution, 500 milliliters of aqueous solution. So I kind of gave you that, but I give it to you in the wrong units. I give it to you in milliliters rather than liters. All right. Do I have the moles of solute? Well, almost. I have the grams of solute. Solute would be NaOH. So first things first, in any of these things, I want to define my solute. My solute would be NaOH. My solvent would be water, just so I know what I'm dealing with when I'm trying to solve the problem. So if my solute is NaOH, then I know which moles I need. I don't need the moles of water, I need the moles of NaOH. Great. So I have 40 grams of NaOH. How do I get the moles of that? Well, I can go to the periodic table and figure that out using the atomic weight, the molecular weight. So I have 40 grams of NaOH, and I will go to the periodic table to determine my dimensional analysis factor here. I'm trying to get rid of grams of NaOH, right? And I'm trying to go into moles of NaOH. And if I go to the periodic table, Na is 23, O is 16, H is 1. You add them up, that's 40. So I did this on purpose. 40 grams of NaOH per 1 mole of NaOH, meaning that I get 1.0 moles of NaOH. Again, I'm assuming I have 2 sig figs. All right. So that's great. So I have this. This now is my numerator here. I have the moles of my solute. Perfect. I almost have my denominator. I have it as 500 mils. I just got to convert it to half a liter to get what I need. So convert 500 mils of solution, and I want to convert that into liters. Well, that's fairly simple. I have 1,000 mils per liter, right? My milliliters would cancel. Great. And I get that this is 0.5 liter solution. Great. So now I'm ready and equipped to get my molarity, which my molarity of the solution would be 1.0 mole of NaOH and divided by 0.500 liters of solution. Sorry, it's being obstructed. I'll move in a sec. And I get that this is a 2 molar NaOH aqueous solution. Okay. Typically, if you just wanna, you can just say 2 molar solution, or 2 molar NaOH, or whatever you want to say. However you want to describe this to be most, to have the most thorough description of it. But 2.0 molar, if you just wrote 2.0 molar, someone might say 2.0 molar what? And then you have to just say, well, NaOH, NaOH and what? So it'll be NaOH aqueous solution. So it just depends on the practicality of how much you need to describe it. If it's pretty apparent, you don't have to write all of that out. So just depending on the question and whoever's asking you. Okay, so that's molarity. And we talked about taking something that is concentrated and trying to dilute it, or diluting it, attempting to dilute and trying to concentrate that. Well, how do I know how much I need to dilute or how much I need to concentrate? Well, so we have what we usually call a stock solution. That is something that is a concentrated solution, and from that I can get more dilute solutions. Okay, so maybe I have something that's 10 molar or 100 molar or something like that. And I have very little bit of it in a stock room, and I want to take from that and make a whole bunch of more dilute solutions. So a practical example of that from the kitchen or something like that. I hate these things, but maybe you have them. Maybe you like those things. You can buy these concentrates that you can you can make a juice out of those, right? So it's like a syrup, a bottle of syrup, and you add that to water. Or you could probably, if you think not just fruit flavored, you can have chocolate flavored. So you can get like one of those Hershey's or Bosco chocolate syrup. You could buy a small bottle of that, and then you can just add that to water or to milk or something, and you can make yourself a cup of cocoa or something like that, or a cup of grape juice if you have the grape juice concentrate, right? So that concentrate stuff is the stock solution that you have. Your goal is to make a consistent cup of milk or a cup of cocoa or a cup of juice each and every time, and so you need to know how much water to add to how much the concentrate to get something that you consider yummy. So that act of doing that is called a dilution. When you do that yourself in the kitchen, you don't really you don't take a calculator or anything, try to figure it out. You just, do by eye or by taste, maybe add a little more water, add a little more concentrate, whatever. You could figure that out, and then you can kind of memorize how much to put for yourself, so something like that. But in chemistry and in engineering, we have a lot less of leeway when we're making stuff. So we should definitely know how to do that consistently. So we don't have to keep guessing every single time how much water to add to get to what we need. And so let's go look at an example. Let's say I have instead of this Bosco syrup, I have 10 molar NaOH solution. Okay, so that would be your concentrate in the fridge or something, right? And I want to make 100 milliliters, which is less than half a cup of 2 molar NaOH solution. Okay, so I want to make something that's more dilute, so it'll be 2 molar. And I want to make 100 milliliters of it. So my question is then, how much of this concentrate, of this 10 molar stuff I need? And obviously I need to add water to that to get to this 2 molar NaOH. So how much water do I need, and how much of this do I need, and how can I mix them together to make this specific thing? Okay, so that's the question. So to do that, you can recognize that the moles of NaOH should be the same in the stock solution as it is in the dilute solution. What do I mean by that? If you go back here, I'm just adding water to get from here to here, right? I'm adding water. NaOH doesn't change, right? The amount of NaOH won't change. Let's just say I take 5 milliliters of NaOH of this stuff, 5 milliliters of this, right? The amount of the moles I have in 5 milliliters of this stuff will be the same if I add 10 liters of water to it or 100 liters of water to it. I'm not changing the amount of NaOH and what I took out of this, right? If you go back to your juice analogy, let's say you take your or Bosco syrup, you squirt out, I don't know, a tablespoon of syrup, right? The amount of pretend chocolate that you have in your cup will be the same, right? You squirted a tablespoon, right? Whether you add 12 cups of milk to it or 5 drops of milk to it, the amount of chocolate is the same, right? So it's the same thing here. If I'm taking the 10 molar, it's the same amount in the concentrated solution as it is in the dilute solution, right? If I'm looking at the definition of molarity, molarity is moles per volume. If I solve for moles, it will be moles equal to molarity times volume, meaning that I can replace the stuff on the left side with big M times big V, and stuff on the right side with big M times big V. And so I get that M concentrated times V concentrated is equal to M dilute times V dilute, okay? Because the moles are the same. So I can, those two are equated. So let's use the values that we had before. I had my Bosco syrup was 10 molar, and I wanted to make a cup of cocoa, and that I defined that as 2 molar, and I want to make less than half a cup because that's all I want to drink. So I have 100 mils, and it has a concentration of 2, and so and I start with 10 molar, meaning that I can solve for V1 fairly easily, and when I do that, I get that's 20 mils. Okay, so V1 is 20 mils. What does it mean? I need to take 20 milliliters of my Bosco syrup, and then I need to add 80 mils of water, and I'll get what I want. That's what that means. Okay, so I need 20 mils of the 10 molar solution and 80 milliliters of just regular water, and I'll come up with my dilute solution. Okay, so hopefully that made sense. Here's another example, very, very appropriate for the times, unfortunately. You maybe your parents bought 91% isopropyl alcohol, rubbing alcohol from the store because they heard that isopropyl alcohol is basically the active ingredient in hand sanitizer. So they said, oh, you know what? I'll just buy that stuff and we don't have to buy hand sanitizer and we're going to save so much money. Great. They bought the 91% because the 70% was there too, but 70% is not as effective as 91%, isn't it? But then they came home and they actually looked it up and they realized, or maybe you told them that, 91% is not as effective at killing germs as 70%, and that's true. 70%, 60 to 70% is what they recommend to killing germs. Anything higher than that doesn't have enough water to actually do the job. So you actually need some water to do that. If you don't have enough, it won't work. So you need 70% isopropyl alcohol. So you bought 91% and now you want 70. So what do? You have to dilute it. So let's say you bought some 91% and you want to know how much of it to add to water to get to 500 milliliters 70%. Okay, so it's the same idea, M1, V1, and 2, V2. My initial concentration is 91%. My final concentration will be 70% with I just prescribed that as half a liter, whatever. If you solve V1, you get 385 milliliters, meaning what? I need to take 385 milliliters of 91% and add enough water to get to 500 milliliters, and I'll get 70%. So this is the calculation here. 385 mils of the concentrated solution and 150 milliliters of water will give me 500 milliliters of 70% IPA. Okay, so next time we'll talk about acids and